Hello everyone. Our today's topic is straight line motions. In this study, we'll be studying about what are the straight line motions, what are the conditions required for exact straight line motion with an example with Peculiar's mechanism. Also, we'll prove that in case of a peculiar mechanism, it follows a straight path, and finally we'll able to calculate the degree of freedom also of the peculiar's mechanism. As we know that there is a point on the mechanism which traces a straight path within the possible limits of motion. So a straight path in a mechanism is traced by a point in the mechanism within prescribed limits. It can be given by two ways, by the use of turning pairs and by the use of sliding pairs, but we normally prefer the turning pair as there is more wear and bulky size of a sliding pair. These two types of mechanisms may provide exact or appropriate straight line motion, as we'll be discussing in the following articles. So what are the conditions for exact straight line motion? Let's consider a figure in which point O be a point on the circumference of a circle of diameter OE. Let any chord OB, as you can see here, chord OB is extended up to point C such that OB into OC is constant, and if OB into OC is constant, then we can say that point C traces the straight line, and this straight line CD is perpendicular to OD, or we can see diameter OE which is extended till D. For this, let's join BE. Now in triangle BOE and DOC, angle O is common in both. Okay. In triangle BOE and DOC, angle O is common. Also angle OBE and ODC both are 90 degree. So we can say that triangle OBE and ODC are similar, and we know that if two triangles are similar, their sides are in equal ratios. That means we can say that OB upon OE is equals to OD upon OC. Or we can say that OD is equals to OB upon OE into OC. Now from this figure we know that OA is a diameter of a circle, so it is constant. Also D is the any extended point on this link OE extended where point perpendicular from point C meet. So OD is also constant. Therefore OB into OC is constant. or we can say OD is constant. Hence point C moves along the straight path CD, which is perpendicular to OD, and exact straight line motion mechanism with turning pairs are described here, which are namely Peculiar's mechanism and Hart mechanism. So as we have proved it as a straight mechanism or a straight line motion, we'll give an example with the help of Peculiar's mechanism. Now let's have a look over the Peculiar's mechanism. Peculiar mechanism, as you can see from the figure, it is a 8-link mechanism in which we have link OA as fixed. Let's name the links first. Let it is link 1, this OC as link 2, this OB as link 3, BP as link 4, BC, BQ as say 5, QC as say 6, and PC as 7, and AQ as 8. Here OA is fixed. There are total 8 links in a mechanism, and Peculiar's mechanism is a straight line motion mechanism which has total 8 links, where link 2 is the driving link. The link OC is the driving link. Let 4, 5, 6, 7 are all of equal lengths, thus formed a closed 4-bar linkage. The pin P and Q are at opposite corners of the 4-bar linkage. The point B and C are connected by link of equal lengths to a fixed pin O. That is, point B is connected by link 3 and point C is connected by link O. Line OA and AQ are of equal lengths. This OA, that is link 1, and 8 are of equal lengths. When link 2, that is AQ, rotates, when link AQ rotates, the product OQ into OP is constant. That is OQ into OP equals to constant. And as we have just discussed in the previous section, if we are able to prove that OP into OQ is constant, then we can also say that point P traces a straight path perpendicular to OA. That is, PX is the locus of the points which point P traces and makes the straight path. Now join BC, as we have already joined, to bisect this point PQ at say F. This is point F. Now from the right angle triangle OBF and triangle BFP, that is right angle triangle OBF, right angled at F, and BFP, that is right angled at F again. OB square is equals to OF square plus BF square. Let it be equation 1. And in the same way, from triangle BFP, hypotenuse is BP. BP square is equals to BF square plus FP square. Say equation second. Now subtracting equation second from first, we'll get OB square minus BP square equals to OF square minus FP square. Yes, BF square and BF square are cancelled. So F square plus BF square minus BF square minus FP square will give this. And we know that A square minus B square is A plus B, that is OF plus FP, and A minus B, that is OS minus FP. And we know that OB is a rigid link, so it is a constant, and also BP is a rigid link, it is also constant. So we can say that OF plus FP into OF minus FP is constant. Or we can say OF plus FP, as you can see from the figure, OF plus FP is equals to OP, right? And OF minus FP, which is further equals to FQ. So we can, in place of FP, we can write FQ also. So it will give OQ, which is equals to constant. Hence proved that OQ into OP is constant. Hence point P traces a straight path PX which is perpendicular to OE, or we can say OA. Hence peculiar mechanism shows the straight line motion. Now we can also calculate the degree of freedom of this mechanism. What is degree of freedom? It is the total number of inputs required for a desired motion. As we have discussed in the previous section, that degree of freedom is F equals to 3 n minus 1 minus 2j minus h, where n is the number of links and j equals to total number of lower pairs, or we can say total number of binary joints. And what is h? It is equals to total number of higher pairs, and in this case there are no higher pairs, as all are the turning pairs which have the surface contact, so there is no line and point contact. So the total number of links, we already know that n is equals to 8 in case of peculiar mechanism. So total number of joints are, or we can say binary joints are, here at point O there is a ternary joint, so we can say 2 binary joints. At point A there is 1. At point Q again there is a ternary joint, so it is equals to 2 binary joint. At point B also it is a ternary joint, as link 3, 5 and 4 are meeting there, so it is also having a 2 binary joint. At point P it is a 1. As 2 links are meeting. And at point C it has 3 links meeting, so it has 2. So 2, 4, 6, 8 and 9 and 10. Total number of binary joints are 10 and H equals to 0. Therefore F is equals to 3 into 8 minus 1, that is 7, minus 2 into 10, that is equals to 21 minus 20 equals to 1. So it requires only degree of therefore it requires only one input for a straight line path, which is given by link 2, which is also known as driving link. So degree of freedom in case of peculiar mechanism is 1, and it is a straight line motion path. Now we can show that
Here
what
we can
is
see
the application of
zigzag
this
motion of
this link. Here we can see that peculiar mechanism is showing a straight path, which is shown by this pointed. So this is the real application of peculiar mechanism, that it helps to trace the straight path. Thank you.